Okay, now let's start implementing what we did. So we started from, for each element from this list we check if it's in element to keep. If it yes, we append to L1. So we start for each element in L. Alright, so it's a for that we have to do. Let's implement this for L element in L. Then we check if element in elements to keep, then L1 dot append element. Alright, so let's run. It's working. Let's do for the next test case. So L is this guy here, elements to keep is this guy here, and the answer is for the second test case where is the second, is here for two. Okay, let's run. It's working. We'll just pause the video, otherwise we'll get too big the video, and I will paste it all test case. Okay, so now I pasted all test cases, everything is passing. Alright, it's testing this function and this function. Okay, so now we have ek L1 L2 L3. Okay, ek is testing, is done and is tested. So done, L1 is done and testing. Alright, tests, now you can see that is very important, because imagine that you didn't do these tests, and specifically on this test case, or in this one, breaks. If it's breaking, the code is not working for this test, it means that this function is not going to work also for this test. So your code is going to have problems here and here. Alright, but because we test everything here, everything is okay. If we get a bug here, probably the bug is here. Alright, so you can see only L1 and you forget about ek. So now let's go to L2. L2. So L2 consisting of the leftmost occurrences of the members of L which are part of elements to keep, preserving the original order. So let's see the tests. So L2 60. So it's saying leftmost occurrences of the members of L which are part of the elements to keep. So all elements of L2 must come from L1. Alright, so I cannot have, for example, 5 here, because I don't have 5 here on L1. And it's saying, so, and it says leftmost occurrence of the members of L. So it looks like that because L1 is composed by elements to keep and also preserves the order of L, it looks like that is only to remove the duplicates and keeping the order of L or L1, right? Because L1 is already keeping the order of L. So let's see. So we have 660, remove the duplicate, we have 6. Alright? So here, for 2 doesn't have duplicates, keep the same. Here, 03, remove, L1, 03303, remove duplicate, 0 with 0, remove duplicate, so 03. So here, we keep the order, so appears 0 first, then 3, 0, then 3. So looks like it's only to remove duplicates from L1. Let's check this one. 3 becomes 1, 6, 0. Correct. Then 7, 5, 1, 1, 1, 1. Yes. Yeah, it looks like that this logic is correct. So 0, 7, 5, that's fine. 9 for 0, 7, 0 already have there, 2, 7 is also fine. 3, 8, okay, 13, alright, 13 is already there, 8 I put, 8, 13 is there, 3, yeah, it's only removing duplicates from L1, alright. Now, the first attempt that we try to do is to convert this list in a set. If we do this, let's see what Python does. Alright, so let me erase this part. Python console. So L equals, let's copy this guy here. If I do set of L, gives me 0, 6. If I convert list of set of L, is going to give me 0, 6. However, I have to keep the order here. Alright? So how to do that? So you can use set and arrange everything after, alright? But one thing that is easier, yeah, and the logic is similar to this one to create L1. So, for example, here we have L2. L2 is empty in the beginning. So we start from this guy. Is 6 for each element of L1, we check, is this element in L2? No, append. Then we go to the next. Is this element in L2? Yes, do not append. Then go to the next. Is this element in this list L2? No, append. 6, 0. Works for this test case. Let's see the next one. This is not a good example because we have same values. Let's get other one. This one, because it's jumping by 2. Alright, try also to find the good test case. You should test for this test case also. Alright, I will not do that because the video is going to get too long. So let's test for this one. So for each element in this one, I check, is this element in L2? L2 in the beginning is going to be empty. No, append. Is this element in L2? No, we have only 0, so append. Is this element in L2? Yes, do not append. 0 is in there, do not append. 3 also, so 0, 3. Alright, work it. So let's go, let me see one. Let me try to find one that is here. So let's test for this guy here. So I have L2. So for each element in L1, is this element in L2? No, because it's empty. So 9. Then I go to 4. Is 4 in L2? No, 4. Is 0 in L2? No, 0. Is 7 in L2? No, 7. Is 0 in L2? Yes, do not append. Is 2 in L2? No. is 7 in L2? Yes, do not append. So 94072, correct. So the logic is correct. Let's implement this. So what we do, let's create function def generate L2 from L1. We only need L1 here, right? So L1 is going to return L2, and we don't need these guys here. We can put, but doesn't make any difference. So L2 is going to be a list test case. Let's put the test case 3 from L1. Then L1 is going to be the first guy here, and I don't have this guy, and the answer is 60, which is the first test case. Alright, so what we do for element in L1, if element not in L2, L2 dot append element. Alright, so let's test. Work it. Okay, we are lucky. Not many bugs today. So let's insert the next tests, all tests. Alright, again I will pause the video and I will insert everything. So I created here all tests. Alright, it's working, no errors. So we finished L2. So far now we did EK, that calls, and then L1 needs EK to do the stuffs, then L2, and now we are going to do L3. Alright, so this part is done. L3 is the last one.